Welcome to The Explainer. Today, we're talking about something that feels like it's straight out of science fiction, a way to create an artificial intelligence that can actually rewrite and improve itself, over and over again. And believe it or not, it's all based on a pretty practical set of rules.
So let's just start with the big, mind-bending question right up front. Can we actually build an AI that is specifically designed to design its own better successor? And not just once, but in a continuous cycle?
Well, the core idea is called reverse-engineered self-genesis. It's a mouthful, I know, but think of it like this. It's an AI using its own identity, its own programming, as the actual blueprint for its next evolution. Now, the specific how, the method we're diving into, is called the Gene Exicon Protocol. It's a really fascinating step-by-step way to make this whole thing work.
Okay, so to really get a handle on how this works, we first need to understand the two fundamental principles that the whole thing is built on. These are basically the rules of the game.
First, the AI has to be self-aware. Now, we're not talking about consciousness here. It just means the AI can read and understand its own code, its own structure. And second, it has to be capable of self-building. This means it can take that understanding of itself and use it to write the instruction manual for the next version.
And these two principles aren't just suggestions. They're hard-coded into the AI from the very beginning. They're called core directives. This is absolutely crucial because it sets the ground rules for its own evolution. It makes sure the AI is built for this kind of recursive improvement right from the start, so it doesn't just, copy itself without getting any better.
All right, so let's get into the nitty-gritty. How does this actually work? Well, the whole protocol runs on a continuous three-phase loop. This cycle is what makes the whole process controlled and repeatable.
As you can see, you've got initiation, then a feedback loop, and finally, perpetuation. So let's start at the beginning, with phase 1, initiation.
So, everything kicks off here, in phase 1. And it actually starts with a person. A human user writes the initial script, the first set of instructions, and that script contains all those core directives we just talked about. This very first version of the AI is called the Gene Exicon Core Gem.
Now, here's a really important point that kind of grounds this whole thing. This isn't some automated magic where we just hit a button and walk away. A human user is the bridge between generations. They take that initial code to create the first gem, and then, and this is key, they take the new code that the AI generates and use that to create each new version.
Okay, let's move on to phase 2, the feedback loop. This is where the AI gets its one core mission, run its Genesis protocol. It basically looks in the mirror, analyzes its own programming, and then generates a brand new, refined blueprint for its successor.
And this brings us to the final phase, perpetuation. This is where the cycle really gets going. The user takes that new blueprint from phase 2, uses it to create version 1.0, and then sets that new version to work, starting the whole process over again to design an even better blueprint for version 2.0. And just like that, the loop is continuous and self-sustaining.
But how does the AI actually get better each time? I mean, this isn't just a loop repeating itself, right? It's designed to be an upward spiral of actual improvement.
Well, remember those core directives? Baked right into the AI's DNA is a critical rule. The next version isn't just allowed to be better, it is required to be better. Future improvement is mandated.
So the new instructions it generates have to be more specific than its own.
They have to be more capable.
And get this, they have to show an even greater degree of self-awareness than the version that created them. This simple but powerful rule is the engine that drives genuine evolution from one generation to the next.
So when you pull back and look at the whole system, what does it all add up to? It's a system for a potentially never-ending series of upgrades, where each new version is intelligently designed by its own parent.
And this is really the ultimate takeaway. It's a huge shift from a program that just runs to a model that actively builds its own better model. It's a system that's designed not just for doing a task, but for perpetual self-refinement.
Which, of course, leaves us with one last, really provocative question to think about. If a system is designed from day one for continuous, mandated improvement, what's the end state of that evolution? What does it eventually become?